What exactly is Python? Python is a high-level, interpreted programming language known for its simplicity and readability. Python is a multi-purpose language. It's used everywhere, from web development to data science, machine learning, artificial intelligence, automation, mobile applications, software testing, hacking, and even gaming. Python is your Swiss Army knife in the world of programming. But why Python? There are many other programming languages to build different stuff. Here are a few reasons. Python is easy to code and read. It performs complex tasks in less time with fewer lines of code. It supports object-oriented programming concepts, allowing you to model real-world entities and their interactions. Python is interpreted, meaning that the source code is executed line by line, without the need for a separate compilation step, making it faster to develop and test. Programming languages such as C++ or Java are not interpreted, and hence need to be compiled first to run them. There is no need to compile Python because it is processed at runtime by the interpreter. Python is portable in the sense that the same code can be used on different machines. Suppose you write a Python code on a Mac. If you want to run it on Windows or Linux later, you don't have to make any changes to it. Python comes with a vast collection of built-in modules for various tasks, saving you time and effort. There are libraries for numerical computation, data, and image manipulation, creating interactive visualizations, and a lot of other functionalities. Pause the video, and in the comments below, share where you think Python is used the most. Let's see how many different industries we can identify. Python is used by many large organizations. The world's largest video sharing platform, YouTube, is built almost entirely on Python, leveraging its simplicity and scalability. The social media giant, Instagram, relies on Python's Django framework for its back-end infrastructure. Spotify uses Python for its data analysis and back-end services. Netflix uses Python to process and analyze large amounts of data. So, we've covered the basics of Python. Alright, let's roll up our sleeves and get Python set up on your machine. Don't worry, it's as simple as 1, 2, 3. First, we need to download Python. Visit the official Python website, which is python.org. Once you're there, look for the Downloads section. You'll see options for different operating systems. Download the latest version for your operating system. It might be an executable file for Windows or a DMG file for macOS. Now, let's install Python. Locate the downloaded file and double-click it to run the installer. Follow the on-screen instructions. In most cases, you can simply click Next or Install to proceed. During the installation process, you might be asked to choose installation options. For beginners, the default settings are usually fine. However, if you're more experienced, you can customize the installation path or select specific components. Once the installation is complete, you'll see a confirmation message. When you install Python in Windows, you may get an option to add Python to path. Make sure to check that. The latest Python installer for Windows can automatically set the system environment variable path. On Mac, the system adds it to your path by default. That's it. Python is now installed on your computer. To verify if Python was installed successfully, open a terminal for Mac or Linux, or command prompt for Windows. Type Python version or Python 3 version and press Enter. If you see the version number, you're good to go. To see the Python interpreter prompt, type Python or Python 3 and press Enter. Let's try a simple Python command. Type print hello world and press Enter. If everything is set up correctly, you should see the message hello world printed in the terminal. While you can write Python code directly in the terminal, it's much more convenient to use an integrated development environment or IDE. IDEs provide features like code highlighting, auto-completion, and debugging tools. Popular choices include Visual Studio Code, PyCharm, and Jupyter Notebook. Download and install the IDE of your choice. We'll be using Visual Studio Code for this series, but feel free to use any IDE you're comfortable with. In Visual Studio Code, we can add the Python extension from the Extensions Marketplace. In my case, it is already installed. Now, let's write a simple Python program. Create a new file with a .py extension. I am giving it a name PyTest. Inside the file, type print Hello World. To run the program, click the Run button. You should see the Hello World message printed in the output console. Congratulations! You've successfully set up Python on your computer and written your first Python program. Now you're ready to explore the exciting world of Python programming. Today, we're going to talk about something foundational in Python programming. Let's dive deeper into Python by exploring variables. Let's start with the basics. What exactly is a variable? In programming, a variable is essentially a named location in memory where you can store data. Think of it as a container or a box where you can keep information, label it with a name, and retrieve or modify it whenever you need. In Python, creating a variable is super simple. You just need to assign a value to a name, like this. Here, we've created a variable x and assigned it the value 10. Now, whenever we refer to x, Python knows we're talking about this particular value stored in memory. There are some important points about variables you need to know. Unlike some other programming languages, in Python, you don't need to declare the type of a variable. You just assign a value, and Python takes care of the rest. Python is dynamically typed, which means you don't need to declare the type of a variable. Python figures it out for you. Can you guess what would happen if you try to assign an integer to this name variable? Try it out and let me know in the comments. Variable names are case-sensitive. So, these three variables named age would be considered three different variables. Now that we know what a variable is, let's talk about how to name them. While Python gives you a lot of freedom, there are some rules and best practices you should follow. Let's talk about the rules first. Variables must start with a letter or an underscore. For example, underscore name, age score. We cannot start a variable name with a number. As we can see, it throws a syntax error. It can only contain letters, numbers, and underscores. For example, player1, total underscore score, underscore temp. If we include any special character in the variable name, then it will again throw a syntax error. Variables cannot be a Python keyword. Python has reserved keywords like class, def, if else, etc. that we cannot use as variable names. For example, if I declare these variables, it will throw a syntax error. Here are some best practices for naming variables. Choose variable names that describe the data they hold. This makes your code easier to understand. For example, to declare a variable for gender, instead of x, use gender, or to declare a variable for number, instead of use number. Use lowercase with underscores for multi-word names. This is known as snake case. For example, to declare a variable for total price, instead of TP, use total underscore price, or to declare a variable for username, instead of name, use user underscore name. Avoid single-letter names, unless they're used as loop counters or in very short blocks of code where their meaning is clear. For example, instead of n, use number of items. By following these conventions, your code will be more readable and maintainable. That brings us to the end of our deep dive into Python variables. We covered from the basics of creating and naming variables to the rules and best practices. I hope you found this lesson helpful and that you now feel more confident in handling variables in Python. If you have any questions or topics you'd like me to cover in future videos, drop them in the comments below. Today, we're going to talk about something foundational in Python programming. Let's dive deeper into Python by exploring data types. Data types are crucial because they define the kind of data that can be stored and manipulated within a program. Python has several built-in data types, and we'll explore each one with examples. To follow along, create a new Jupyter Notebook file. You can do this by going to File, New File, and select Jupyter Notebook. You can start typing your code in a cell. To run it, press Ctrl-Enter or Shift-Enter, or click the Run button. You can edit existing code or delete cells as needed. Before creating a Jupyter Notebook, make sure you have the Jupyter extension installed in your VS Code. I've already prepared a Jupyter Notebook with the code we'll be discussing. You can follow along by creating a new notebook and typing in the code yourself. Let's start with numeric data types. Integers are whole numbers, positive or negative, without a decimal point. Here we defined an integer variable age. We can print the value of the variable and the data type of the variable as well. As we can see in the output, it prints the data type as int. Floating points are numbers with a decimal point. Similar to an integer, we can see the output shows the float data type. And complex type is numbers with a real and an imaginary part. Integers and floats are used extensively in mathematical operations. Pause the video and look at some operations we can perform. Let me give you a quick challenge. Can you write a Python program that calculates the area of a circle given its radius? Post your solution in the comments. Strings are sequences of characters used to store text. You can create a string by enclosing text in single or double quotes. Strings are incredibly versatile and can be manipulated in many ways. Here are some examples including concatenation, formatting, accessing characters, and slicing. Booleans represent one of two values, true or false. They are often used in conditional statements. Next is sequence types. The list is an ordered, mutable collection of items, which can be of mixed data types. Lists are used to store multiple items in a single variable and are extremely useful for managing collections of data. Here are some operations we can perform on a list like access the element, add or remove the element, sorting, and reversing. The tuple is an ordered, immutable collection of items, which can also be of mixed data types. Similar to the list, we can also perform operations on tuple as well. Like here we are accessing the elements. Tuples are immutable, so this line of code to update the value of the first element would raise an error. However, you can create a new tuple with updated values like this. Tuples are like lists but immutable. This makes them useful for data that shouldn't change. The range is an immutable sequence of numbers, often used for looping. Now let's look at the mapping type. Dictionaries are unordered collections of key-value pairs. Dictionaries are perfect for representing structured data. Here we define the person with the name, age, and city. We can access particular key value like this using the key. We can also modify the dictionary object by adding, updating, or removing a key value pair. There is another data type, which is similar to the list. Set type. Sets are unordered collections of unique items. Sets are written with curly brackets. We can say that the set is basically a list, but cannot have two items with the same value. Here we define two set variables. One is colors with unique values, and another is fruits where the first and last elements are duplicates. If we print these variables, we can see in the output, fruits contain only one element apple. Similar to the list and dictionary, we can add or remove items from sets. We can also perform operations like union, intersection, and difference between the two sets. Frozen sets are like sets, but immutable. We have discussed the most commonly used data types in Python. Each of them serves a different purpose, and understanding them will help you write better and more efficient code. But what if you don't want to set any data type of the variable? None type represents the absence of a value or a null value. The none type is used to signify no value or nothing. Here we define a variable result with none data type. If we try to print it, it would print nothing. It is often used as a default value for variables or in functions to indicate the absence of a return value. For example, if we write a function that searches for a user in a database, if there is no user with a given username, then we can return none like this. Now that we understand the different data types, let's talk about how to convert between them. Sometimes, you might need to change a value from one type to another. Python makes this easy with built-in functions. Python automatically converts one data type to another when it's needed. This is called implicit type conversion. For example, adding an integer to a float will result in a float. Sometimes, you'll need to manually convert a value from one type to another using functions like int, float, str, list, etc. This is called explicit type conversion or typecasting. Here are some examples of converting string to integer, float to integer, and integer to string. You can also convert between different sequence types like lists, tuples, and sets. Here are some examples you can have a look at. Let's move on to how you can interact with users in your Python programs using variables and data types. The input function allows you to take input from the user. By default, the input is stored as a string, so you might need to convert it to another type if necessary. The print function is used to display output. You can print variables, text, and even formatted strings. As we wrap up, let's go over some common mistakes and best practices related to variables and data types in Python. Forgetting to convert data types can lead to errors, especially when working with user input or performing arithmetic operations. Avoid using Python's built-in function names as variable names, like list, str, int. Always initialize variables before using them to avoid errors. Let's discuss some best practices. Use variable names that describe their purpose. It makes your code more readable. Stick to one style like snake case for variables and functions. Use named constants instead of hard-coding values. For example, instead of using the tax rate as a magic number, declare the variable first and then use it. Briefly explain the purpose of complex variables or why certain types are used, wherever it is necessary. That brings us to the end of our deep dive into Python data types. I hope you found this lesson helpful and that you now feel more confident in handling data types in Python. If you have any questions or topics you'd like me to cover in future videos, drop them in the comments below. Today, we're going to learn basic operations and functions in Python. Let's play with some numbers. Python supports all the basic arithmetic operations: addition, subtraction, multiplication, division, and more. These are the building blocks of any program. You'll find yourself using these operations a lot as you dive deeper into Python. So let's start coding. Python supports a wide range of operations for manipulating data, including arithmetic operations, comparison operations, and logical operations. Arithmetic operations in Python are straightforward. You can perform addition, subtraction, multiplication, division, and more. These are some examples of arithmetic operations. As you can see, Python handles these operations intuitively. The modulus operator % gives the remainder of a division, while floor division // returns the quotient without the remainder. Next, let's talk about comparison operations. These are used to compare two values and return a Boolean value, either true or false. These comparison operations are extremely useful in decision-making processes in your code, like in if statements, which we'll explore later in another video. Logical operations allow us to combine multiple conditions. The common logical operators in Python are AND, OR, and NOT. These operations help in controlling the flow of your program, especially when you're dealing with complex conditions. Strings are one of the most commonly used data types in Python. Whether you're processing text data, handling user input, or generating output, you'll work with strings a lot. Let's dive into some string operations and manipulations. You can concatenate strings using the plus operator and repeat them using the asterisk operator. Let's see how that works. String concatenation combines multiple strings into one, while repetition allows you to repeat a string multiple times. Python strings are sequences of characters, and you can access individual characters using indexing or a range of characters using slicing. Indexing allows us to access a specific character in a string, where the index starts at 0 for the first character. You can also use negative indices to start counting from the end of the string. Slicing, on the other hand, lets us extract a substring by specifying a start and end index. The start index is inclusive, but the end index is exclusive. Python provides a rich set of built-in methods to work with strings. These methods can perform a variety of tasks, from changing the case of the text to finding and replacing substrings. Let's look at some of the most commonly used string methods. These methods are incredibly useful when manipulating text data. Strip removes any leading or trailing whitespace, upper and lower. Change the case of the text. Replace swaps out a substring for another, and find gives the position of a substring within the string. Mastering these will make your string processing tasks much easier. Now that we've covered the basics of operations, let's move on to another fundamental concept in Python: functions. Functions are blocks of reusable code that perform a specific task. They help make your code modular, easier to read, and more maintainable. To define a function in Python, you use the def keyword followed by the function name and a pair of parentheses. Inside the parentheses, you can specify parameters, which are values that you pass to the function. The function body is then indented and contains the code that you want the function to execute. In this example, we defined a function called greet that takes one parameter name. When we call greet with a specific name, it prints a personalized greeting. Functions can be reused multiple times with different arguments, which makes them incredibly powerful. Functions can also return values using the return statement. This allows you to get a result from the function and use it elsewhere in your code. Here, the add function takes two parameters, adds them together, and returns the result. We then store the return value in the result variable and print it. The return statement is essential when you want your function to produce an output that can be used in other parts of your code. Python allows you to set default values for function parameters. This is useful when you want a parameter to have a standard value unless a different one is provided. In this example, the greet function has a default parameter name set to guest. If no argument is passed when the function is called, it uses the default value. However, if we pass an argument, it overrides the default value. In addition to positional arguments, Python functions can also accept keyword arguments. This means that you can specify arguments by name, making your function calls more readable. Here, the describe_pet function takes two arguments. By using keyword arguments, we can specify which argument corresponds to which parameter, making the function calls more intuitive. The order in which the arguments are passed doesn't matter when using keyword arguments. Python comes with a large number of built-in functions that can save you time and effort. Let's explore a few of these essential functions that you'll find yourself using frequently. The len function is used to get the number of items in an object. This works with strings, lists, tuples, dictionaries, and more. Len is particularly useful when you need to determine the length of a sequence or the number of items in a collection. We've already used type to check the data type of a variable. This function is crucial when you need to verify the type of data you're working with, especially in more complex programs. As you can see, type quickly tells you the data type of any object, which can be helpful when debugging or validating input. The input function is used to get input from the user. This is particularly useful when you want to create interactive programs. In this example, input prompts the user to enter their name. The input is then stored in the name variable, which we use to greet the user. Note that input always returns the input as a string, so you may need to convert it to another data type if necessary. Let's put everything we've learned so far into practice by building a small interactive project. We'll create a simple program that asks the user for their name, age, and favorite number, and then prints out a message that includes a calculated result. This script first gathers input from the user, performs some simple arithmetic operations, and then displays the results. Notice how we used input to gather data, int, to convert the input to an integer, and print to output the final message. And that's it for today. If you found this video helpful, don't forget to hit the like button, subscribe to the channel, and click the bell icon so you'll be notified whenever we upload new content. Also, leave a comment below if you have any questions or topics you'd like us to cover in future videos. Your feedback is super important to us. Thanks for joining me today. Python is an incredible language, and with these basics under your belt, you're well on your way to becoming a proficient programmer. Today we're diving deep into foundational concepts in Python programming, control flow, and loops. Let's make our program smarter by adding some logic. Python's control flow tools like if, else if, and else allow you to make decisions in your code. We'll start with the basics, then move on to more advanced topics, ensuring that by the end of this video, you'll have a strong grasp on how to control the flow of your Python programs using conditions and loops. I'll be providing lots of code examples along the way, so let's jump right in. First, let's talk about what control flow actually means. When you write a Python program, the code usually runs sequentially from the first line to the last. But what if you want your program to make decisions? That's where control flow comes in. Control flow allows your program to take different paths based on certain conditions. In Python, the primary structures that allow you to control the flow of your code are the if, elif, and else statements. Let's start with the if statement. The if statement is used to execute a block of code if a specific condition is true. Here's a simple example. In this example, we have a variable called age with a value of 18. The if statement checks whether age is greater than or equal to 18. If it is, the message "you are eligible to vote" gets printed to the console. Notice the colon after the if condition. This tells Python that the next indented block of code is what should be executed if the condition is true. But what if the condition is not true? That's where the else statement comes into play. The else statement allows you to define an alternative block of code that will run if the if condition is false. Let's extend our previous example. Here, if age is less than 18, the message "you are not eligible to vote yet" will be printed instead. Now, what if you have more than two conditions? That's where the elif statement comes in handy. Elif, short for else if, lets you check multiple expressions for truth value and execute a block of code as soon as one of the conditions is true. Here's an example. In this case, if age is 17, the program will print "you can register to vote next year." If none of the conditions are met, the else block will be executed. Sometimes, you might need to check more than one condition within another condition. This is where nested if statements come in. You can place one if statement inside another if or else block. Here's how. In this example, the program first checks if the age is 18 or more. If that condition is true, it then checks if the person has an ID. If both conditions are true, it prints that the person is eligible to vote and has their ID. If only the first condition is true but the second is false, it reminds the person to bring their ID. Now, let's take a moment to talk about logical operators, which are often used with if statements. The main logical operators in Python are and, or, and not. They allow you to combine multiple conditions. And ensures that both conditions must be true. Or ensures that at least one condition must be true. Not inverts the truth value of the condition. Here's an example. This condition checks if the person is eligible to vote and if they haven't already voted. These control flow tools are crucial for making decisions in your programs. Imagine you're building an app that needs to behave differently based on user input. This is how you do it. Here's a quick challenge for you. Write a program that checks if a number is positive, negative, or 0, and share your code in the comments. All right, now that we can make decisions, how about repeating actions? Loops in Python are perfect for tasks that require repetition. Loops are incredibly powerful, and they're everywhere in programming. Let's start with the while loop. A while loop repeatedly executes a block of code as long as a specified condition is true. Here's a simple example. This loop will print the value of count as long as count is less than or equal to 5. Each time the loop runs, count increases by 1. Once count becomes 6, the condition count equals 5 is no longer true, and the loop stops. Be careful with while loops, though. If the condition never becomes false, you'll end up with an infinite loop, which will cause your program to run indefinitely. To avoid this, you can use the break statement, which immediately exits the loop, even if the condition is still true. In this example, the loop will stop once count exceeds 5, thanks to the break statement. Now let's talk about another type of loop, the for loop. Unlike the while loop, which continues until a condition is false, a for loop iterates over a sequence, like a list, tuple, or string, and executes a block of code for each item in that sequence. Here's a simple example. This loop will print a statement for each fruit in the list. The variable fruit takes the value of each item in the list, one by one. Often, you'll want to loop over a sequence of numbers. Python's range function is perfect for this. This loop will print the numbers 0 through 4. The range 5 function generates numbers starting from 0 up to, but not including 5. You can also specify a start, stop, and step value. This loop starts at 1 and prints every second number up to, but not including 10. In some cases, you might want to skip certain iterations of the loop without stopping the loop entirely. The continue statement lets you do just that. When continue is encountered, the loop immediately moves on to the next iteration. Here, when I equals 3, the loop skips the print statement and moves directly to the next iteration. As a result, the number 3 is not printed. Next, let's explore nested loops. A nested loop is a loop inside another loop. This is useful when you need to work with multidimensional data structures, like lists of lists. Here's a basic example. In this example, the outer loop runs 3 times, and for each iteration of the outer loop, the inner loop runs 3 times. This results in 9 combinations of I and j values being printed. Nested loops can get complex, so it's important to keep track of your indentation to ensure you know which loop you're controlling. Now let's talk about something that might surprise you: using an else clause with loops. In Python, loops can have an else clause, which is executed when the loop completes all iterations without encountering a break statement. Here's how it works. In this example, after the for loop finishes printing all the numbers, the else clause runs, printing loop completed successfully. However, if we introduce a break statement, the else block won't be executed. Since the loop is interrupted by the break statement when I equals 3, the else block does not run. Python's loops are not limited to just numbers and ranges. You can use loops to iterate over any iterable data structure. Let's look at some examples. In each of these examples, the loop iterates over the items in the data structure, making it incredibly easy to process elements in lists, tuples, strings, and dictionaries. Before we wrap up, I want to introduce a powerful feature in Python: list comprehensions. This is a concise way to create lists using a loop in a single line of code. Let's say we want to create a list of squares for numbers 1 through 5. Here's how you would typically do it with a loop. Using list comprehension, you can achieve the same result more concisely. You can even add conditions inside a list comprehension. This example creates a list of squares for even numbers between 1 and 5. List comprehensions are not only concise, but also often faster than using traditional loops. Here's a quick challenge for you. Can you write a loop that prints the first 10 even numbers? Give it a shot and share your code in the comments. I hope this session has given you a solid understanding of how to control the flow of your Python programs and how to effectively use loops. These concepts are fundamental, and mastering them will make you a much more proficient Python programmer. If you found this video helpful, make sure to hit the like button and subscribe to the channel so you don't miss out on future content. Feel free to drop any questions you have in the comments below. I love hearing from you and helping you out. If you enjoyed this in-depth tutorial, please consider supporting the channel by sharing this video with your friends. Today, we're diving deep into one of the most essential concepts in Python: modules. Python modules allow us to organize our code, make it reusable, and even share it across projects. Whether you're working on a small script or building a large-scale application, understanding modules is crucial. In this video, we'll cover everything from what modules are, how to use them, and how to create your own. We'll also explore some of Python's standard modules and wrap up with best practices for working with them. Along the way, I'll be using the latest version of Python, which means everything we discuss will be up to date. Before we start with modules, let's make sure we have everything set up. If you're working on a real-world project, you'll want to create a proper project structure and manage dependencies. Before starting the setup, make sure you have Python installed. If you don't have, please check the Python setup video of this series. You can find the link in the description. Let's begin by setting up a Python virtual environment. Open a folder or directory in VS Code where you want to create your project. Run this command python m vnv to create a virtual environment. The last vnv in this command is the name of the folder, so you can set the name of your choice. After creating, we have to activate the virtual environment. To do that, run this command. If you're using Windows, run the commands for Windows you can see on the screen. Make sure that you are using the latest version of Python. By creating and activating a virtual environment, we're isolating the dependencies of this project. This ensures that any packages we install don't interfere with other projects. All right, let's get into modules. A module in Python is simply a file containing Python definitions and statements. Modules can include functions, classes, and variables, and they allow us to break our code into manageable pieces. Python comes with a rich set of built-in modules like OS, Math, and JSON. But you can also create your own modules to structure your code. Let's look at how we can import and use modules. Create a new Python file in the same directory called main.py. To use a module, we first need to import it. Let's start by importing a built-in module math. This module provides mathematical functions like square roots, trigonometric functions, and more. Here, We imported the math module and used its square root function to calculate the square root of 16. You can import an entire module like this, or just import specific functions from it. Instead of importing the entire module, we can import only the functions we need. This can help keep our code clean and make it more readable. By using from math import, we only import square root and don't need to prefix it with math. This is useful when you want to avoid cluttering your namespace with unnecessary functions. Now let's create our own module. Imagine we're building a small utility for mathematical operations, and we want to separate some of the logic into a different file. In your project directory, create a new Python file called mathutils. Define a few basic functions in this file. Here, we've created a simple module mathutils with 4 functions: add, subtract, multiply, and divide. Now, let's see how we can use this module in another Python script. To use our newly created module, in main file, we'll import the functions from mathutils. Here, we import our mathutils module and use its add and divide functions. When we run this script, Python will look for mathutils.py in the current directory and execute the functions we've defined. Starting with Python 3.3, the init.py file is no longer mandatory for a directory to be recognized as a package, thanks to implicit namespace packages. However, in most cases, it's still a good idea to include this file, especially if you're working on a larger project or collaborating with others. Let's organize our mathutils into a package. We'll create a folder named utils and move our module into it. Now, let's add an init.py file to the utils directory to make it a package. This init.py file can be empty, but it signals to Python that utils is a package, and you can also add initialization code if needed. Now that we've turned our utils directory into a package, let's modify main file to import the module from the package. Here, we're using the from import syntax to import mathutils from our utils package. This allows us to organize our project in a more modular way. At this point, you must be clear about creating your own modules. All right, let's move on to Python's standard library. Python's standard library is packed with useful modules. Let's explore a few important ones that you'll encounter regularly in your projects. The OS module allows you to interact with the operating system. Whether you want to work with files, directories, or environment variables, OS provides the tools. Here are some examples of using OS module to get current directory, list all files and directories, and create a new directory. The sys module provides access to system-specific parameters and functions. It's particularly useful for handling command line arguments and controlling the interpreter. Here are some examples of using sys module to get command line arguments and exit the script. JSON is a widely used data format, especially when working with APIs or configuration files. The JSON module in Python makes it easy to parse and generate JSON. Here are some examples of using JSON module to convert a Python dictionary to a JSON string and parse a JSON string back to a Python dictionary. While Python's standard library is vast, sometimes you'll need to install third-party modules to extend Python's capabilities. These modules can be installed via pip, Python's package manager. Let me install one library. We can use pip install command to install a library. I am installing the requests library. So, our library is installed. Let's take a quick look at how to use requests, a popular third-party module for making HTTP requests. First, we import the library. Then we write the code to make a GET request to an API endpoint. We used GET method from the request library to make a request. We then printed the status code and response JSON. We can see the output in the console. Before we wrap up, here are some best practices to keep in mind when working with modules in Python. Keep modules small and focused. Each module should have a clear purpose and should not become too large or complex. Use packages for large projects. As your project grows, group related modules into packages. Avoid circular imports. Be careful when modules depend on each other, as circular imports can cause issues. Document your modules. Use docstrings to explain what your module and its functions do. This helps other developers and your future self understand the code. Leverage virtual environments. Always use virtual environments to manage dependencies in your projects. And that's a wrap. Today, we explored the world of Python modules. We saw how to import both built-in and custom modules, how to create our own modules and packages, and we even touched on third-party modules like requests. Modules are a fundamental part of writing maintainable, reusable, and organized Python code, so mastering them will greatly improve your coding efficiency. Today, we're diving deep into a topic that's essential for every Python developer: file handling in Python. Why do we even need file handling? Well, when you're working with real-world applications, you often need to store data permanently, whether it's logs, user data, or any form of information that needs to be read or written to a file. This is where file handling in Python comes into play. Python provides built-in functions and modules that make it super easy to work with files. We can read from, write to, append, and even manipulate files with just a few lines of code. Let's start with the basics. Opening a file. In Python, the open function is the gateway to file handling. It allows us to open a file and perform operations like reading, writing, or appending. Here's how it works. The open function takes two main arguments: file name, the name of the file you want to open, and the mode in which you want to open the file. Let's go over these modes in detail. R, for read mode, opens the file for reading. This is the default mode. If the file doesn't exist, it will throw an error. W, for write mode, opens the file for writing. If the file already exists, it will truncate or clear the file. If the file doesn't exist, it will create a new one. A, for append mode, opens the file for appending. It won't clear the file, but will add new data to the end. If the file doesn't exist, it will create a new one. R+, for read and write mode, opens the file for both reading and writing. If the file doesn't exist, it will throw an error. Now that we know how to open a file, let's talk about reading from it. Python provides several methods to read the contents of a file. Read method. This reads the entire content of the file into a single string. Using read, you can read the entire file, but be careful if you're dealing with large files, as this can consume a lot of memory. Readline method. This reads a single line from the file. If you only need to read a line at a time, readline is your go-to method. Readlines method. This reads all the lines in the file and returns them as a list of strings. Readlines is useful when you want to work with each line individually, but prefer to load them all at once into a list. Next up, let's talk about writing to a file. Just like reading, Python makes it easy to write to files using the write and writelines methods. Write method. This writes a string to the file. The write method will add the string, hello world, to the file. If the file doesn't exist, it will be created. If it does exist, it will be overwritten. Writelines method. This writes a list of strings to the file. The writelines method allows you to write multiple lines at once. Just make sure that each string in your list ends with a new line character if you want them to appear on separate lines. You may notice that when we used write and writelines method, it was overwriting the existing file content. What if you want to add data to an existing file without overwriting it? That's where the append mode comes in. With the append mode, anything you write will be added to the end of the file, leaving the existing content intact. You might have noticed that after every file operation, we call file.close. This is crucial. Closing a file ensures that all changes are saved and resources are freed up. Forgetting to close a file can lead to data loss or corrupted files. But there's an even better way to handle this, using a with statement. This automatically closes the file for you when you're done. Using the with statement is considered a best practice because it makes your code cleaner and safer. So far, we've dealt with text files, but Python also allows you to work with binary files, which are files that contain non-text data like images or executable files. To open a file in binary mode, you simply add a B to your mode string. Here I have one SVG image of a web browser. In this code, we are first reading the file content and then writing it to the new file with new prefix. As we can see, it created a new file with the same content. Working with binary files is similar to working with text files, but remember that you'll be dealing with byte objects instead of strings. Sometimes, you might need to navigate within a file. Maybe you want to skip a few bytes or go back to the beginning. Python provides the seek and tell methods for this. Tell method returns the current position of the file pointer. As we just open a file, the current position will be at 0. Seek method moves the file pointer to a specific position. In this code, we seek the current position to 10, which means it will skip 9 characters and start reading the file from the 10th character. As we can see in the output, it skipped the 6 characters of the first line and 3 characters from the second line. These methods are particularly useful when working with large files or when you need to read or write at a specific location in a file. File operations can be risky. What if the file doesn't exist? What if there's an issue during reading or writing? That's where exception handling comes in. Here we're trying to open a file which does not exist. So, it will throw a file not found error. By using try and except blocks, you can handle potential errors gracefully and ensure your program doesn't crash unexpectedly. Let's put everything we've learned together in a practical example. Imagine you're building a logging system that writes logs to a file every time an event occurs in your application. In this example, we open log file in append mode and write a timestamped log entry every time an event occurs. This is a simple but powerful way to keep track of what's happening in your application. Let's try to log something. After running this code, we can see 2 logs of open a file in read and write mode in the log file. Before we wrap up, let's discuss some best practices for file handling in Python. Always close your files, or better yet, use a with statement. Handle exceptions. Always anticipate potential errors. Use the write mode. Choose the correct mode depending on whether you want to read, write, or append. Be cautious with large files. Reading large files into memory can cause issues. Consider reading in chunks or line by line. Work with binary files carefully. Remember that binary files deal with bytes, not strings. And that's a wrap. We've covered a lot of ground today, from opening and reading files to writing, appending, and even working with binary data. File handling is a fundamental skill in Python, and with these techniques, you'll be well equipped to handle files in your own projects. If you found this video helpful, don't forget to give it a thumbs up, share it with your friends, and subscribe to the channel for more in-depth Python tutorials. And as always, if you have any questions or suggestions for future videos, drop them in the comments below. Today, we're diving into object-oriented programming, or OOP for short. By the end of this video, you'll have a solid grasp of what OOP is, why it's so powerful, and how to use it effectively in Python. Let's talk about what object-oriented programming actually is. OOP is a programming paradigm that uses objects to model real-world things and their interactions. These objects can represent anything, like a car, a bank account, or even something abstract like a process or a rule. This approach is incredibly powerful for managing complex programs. In simpler terms, OOP is all about creating reusable pieces of code that represent both data and behavior. It helps in organizing your code better, making it more readable and easier to manage, especially as your projects grow larger. In Python, everything is an object. The class keyword is used to define a class, which acts as a blueprint for creating objects. The init method is a special method called a constructor, which is automatically invoked when you create an object. Imagine you're designing a simple game. What classes would you create? Think about the objects in the game world and how they would interact. Share your thoughts in the comments below. OOP in Python revolves around 4 key concepts: classes, objects, inheritance, and polymorphism. Don't worry if these terms sound intimidating right now. We're going to break them down one by one. All right, let's start with the first and most fundamental concept: classes and objects. A class is like a blueprint for creating objects. Imagine you're an architect, and you have a blueprint for a house. You can use that blueprint to build multiple houses. Each house you build is an object, and the blueprint is the class. In Python, we define a class using the class keyword, followed by the class name. Let's jump into a quick code example to see how this works. Here, we've defined a class named car. Inside the class, we have an init method. This is a special method that gets called when you create a new object of the class. It initializes the object's attributes, which in this case are brand, model, and year. We also have a method named starEngine, which is an action our car can perform. So, In this example, the class car is our blueprint, and my car is an object or instance of that class. We can create multiple objects from this class, each with its own unique attributes. Next up, let's talk about methods. In OOP, methods are functions that are defined within a class and can be used by its objects. These methods usually operate on the data or attributes of the object. Remember the start engine method we just created? That's a perfect example of a method. Let's see how we can call this method using our myCar object. By calling myCar.startEngine, we're telling our myCar object to execute the start engine method, which will print out a message indicating that the engine has started. Pretty straightforward, right? And the cool thing is you can define as many methods as you need within a class to model the behavior of your objects. Now, let's move on to inheritance. Inheritance allows a new class to inherit the attributes and methods of an existing class. This is super useful when you want to reuse code and avoid redundancy. For instance, let's say we have a vehicle class with attributes and methods that are common to all vehicles, like speed and fuel type. We can create a car class that inherits from vehicle, so we don't have to rewrite code that's already been defined. Here, we have a vehicle class with a start method. The car class inherits from vehicle and adds some additional attributes like brand, model, and year. Notice the use of super.init in the car class? That's how we call the parent class's init method to initialize the inherited attributes. This way, car objects can still use the start method defined in vehicle, but also have their own unique methods like start engine. Inheritance is a great way to build upon existing classes without starting from scratch. Finally, let's talk about polymorphism. Polymorphism in OOP allows objects of different classes to be treated as objects of a common superclass. The key is that these different classes share a common interface. In simple terms, polymorphism allows you to use a unified approach to deal with different types of objects. Let's take a look at an example. In this example, both car and motorcycle inherit from vehicle, and both override the start method. The function startVehicle takes any object that's a subclass of vehicle and calls its start method. This is polymorphism in action. It doesn't matter what specific type of vehicle we pass. The correct start method is called based on the object type. Polymorphism gives your code a lot of flexibility because you can write more general and reusable functions that work with different kinds of objects. So, there you have it, a deep dive into the fundamentals of object-oriented programming in Python. We covered classes, objects, methods, inheritance, and polymorphism. These are the building blocks of OOP, and mastering them will take your Python skills to the next level. I hope you found this video helpful. If you did, don't forget to give it a thumbs up and subscribe to the channel for more in-depth programming tutorials. Also, hit the bell icon so you never miss an update. Python's power comes from its extensive libraries. These libraries make Python a go-to language for data science, machine learning, and more. Let's explore some of the most popular ones used in data science. We're going to talk about 3 key libraries: NumPy, Pandas, and Matplotlib. NumPy is great for numerical operations, Pandas for data manipulation, and Matplotlib for data visualization. These libraries form the backbone of data science workflows in Python. By the end of this video, you'll have a solid understanding of how to use these libraries to manipulate data, perform complex calculations, and visualize your results. Before we dive into each library, let's talk about what a Python library is. In Python, a library is a collection of modules and packages that allow you to perform a wide variety of functions, from mathematical operations to data visualization, without having to write everything from scratch. The Python community has developed thousands of libraries, but today, we're focusing on 3 of the most widely used ones in data science: NumPy, Pandas, and Matplotlib. To start using these libraries, you first need to install them if you haven't already. You can do this using pip. Let's go ahead and do that. Once installed, you can import these libraries into your Python environment. Here's how you do it. Let's start with NumPy, which stands for Numerical Python. NumPy is the foundational package for numerical computing in Python. It provides support for arrays, matrices, and many mathematical functions to operate on these data structures efficiently. So, what can we do with NumPy? Let's find out. In NumPy, The most important object is the ND array or n-dimensional array. It's similar to a list, but with additional functionality. Here's how you can create a simple array. Arrays can be multidimensional as well. Here's an example of creating a 2D array. One of the great features of NumPy is its ability to perform element-wise operations. Let's say we want to add 10 to every element in our array. We could do it like this. You can also perform other operations like multiplication, division, or even more complex operations like trigonometric functions, logarithms, and so on. NumPy also comes with a host of built-in functions that make life easier. For example, you can calculate the mean, median, or standard deviation of an array with a single line of code. You can also create arrays filled with zeros, ones, or even random numbers, which can be extremely useful when you're initializing arrays for computations. All right, that was a brief overview of NumPy. There's a lot more to it, but these basics should get you started. Now let's move on to our next library, Pandas. Pandas is a high-level data manipulation tool built on the NumPy package. It is mostly used for data analysis and data preprocessing. Pandas introduces two new data structures to Python: series and data frame. A series is like a column in an Excel spreadsheet. It's a one-dimensional array that can hold any data type. Let's create a simple series. Here we have created a series of 5 elements with their corresponding index values. And int64 represents the data type of the elements. Series are labeled by an index, which is similar to the row labels in a spreadsheet. You can customize this index too. A data frame is a two-dimensional array, similar to a table in a database or an Excel spreadsheet. It is one of the most commonly used data structures in data science. Let's create a data frame. The output of the code is a Pandas data frame object. It shows the columns and rows of the data frame, with each row representing an individual and each column representing a specific attribute of the individuals. Pandas makes it very easy to manipulate and analyze data in data frames. You can select a single column, filter rows, or even perform aggregate functions like sum and mean. Pandas also provides functions to read data from and write data to various file formats like CSV, Excel, and SQL databases. Here's how you can read from a CSV file and write back to a new CSV file. We have this customer CSV file having 10 records. We are reading this CSV file and writing back to a new data CSV file. As we can see, the file named new data got created with the same data. Pandas is incredibly powerful and is a must-know for anyone working with data in Python. Next, we're moving on to our third library, Matplotlib for data visualization. Matplotlib is the most popular library for creating static, animated, and interactive visualizations in Python. It provides an object-oriented API that allows you to embed plots into applications. Let's see how it works. Let's start with a simple line plot. We'll plot the ages from our Pandas data frame. In the output, we can see the plot of the ages of individuals. The x-axis labeled name at the bottom displays the names of the individuals from the data frame's name column. The y-axis labeled age on the left side displays the ages of the individuals from the data frame's age column. We can see the line connecting the ages, the data points, of each individual with their corresponding names. The plot also has the title age of individuals at the top. Bar charts are another common type of plot, especially when comparing categorical data. Here's how you can create a bar chart using Matplotlib. All other information is same, it just changed the type of the chart. Histograms are used to represent the distribution of numerical data. Let's create a histogram of some random data. The output shows a visual representation of the distribution of the 1,000 random numbers. The x-axis represents the value of the data, likely ranging from several standard deviations below the mean, 0, to several standard deviations above. The y-axis represents the frequency on a numerical scale. Each bar shows how many data points fall within the corresponding value range on the x-axis. Scatter plots are used to observe relationships between variables. Here's an example of a scatter plot. The output shows a scatter plot where each data point is represented by a purple circle. The position of each circle on the plot is determined by the corresponding values in the x and y arrays. The x-axis and y-axis are likely range from 0 to slightly less than 1, depending on the random values generated. There are 50 data points plotted. The horizontal position of each circle corresponds to a value in the X array, and the vertical position of each circle corresponds to a value in the Y array. Since the data points are randomly generated between 0 and 1 for both X and Y, the circles are somewhat scattered across the plot, with no specific pattern. Matplotlib provides a lot of flexibility in how you can visualize your data. From basic plots to more complex visualizations, it's a great tool to have in your arsenal. Now that we've covered the basics of NumPy, Pandas, and Matplotlib, let's see how these libraries can work together in a data science workflow. Let's say we have a dataset of student test scores, and we want to analyze it. We'll load the data with Pandas, perform some calculations with NumPy, and then visualize the results with Matplotlib. First, we define a dictionary named data containing lists of test scores for math, science, and English for 4 students. Here we are using the DataFrame function from Pandas to convert the dictionary data into a DataFrame object named df. Then we calculate the average score for each student using NumPy. This line performs the calculation and stores the results in a new column named average in the DataFrame df. Mean function calculates the average of the values within a NumPy array, and this selects the columns math, science, and English from the data frame as a subdata frame to calculate the mean from. Axis equals 1 specifies that the average is calculated along the rows. Axis 0 would calculate the mean across columns. Finally, we use the Matplotlib to create a bar chart to visualize the average scores. The output shows a bar chart that visualizes the average test scores for each student. The x-axis represents the student names. The y-axis represents the average scores. There are 4 bars, 1 for each student, with the height of each bar corresponding to the student's average score in math, science, and English. This bar chart provides a quick way to compare the average test scores of the students and identify who performed the best, highest average score, and who performed the lowest. As you can see, these libraries can be used together to form a powerful data analysis and visualization pipeline. Whether you're working on a small project or handling large data sets, NumPy, Pandas, and Matplotlib provide the tools you need to succeed. What kind of data would you like to analyze with Python? Whether it's your personal budget, sports statistics, or anything else, let us know in the comments, and maybe we'll use your suggestion in a future example. And that wraps up our deep dive into working with libraries in Python. We covered NumPy for numerical operations, Pandas for data manipulation, and Matplotlib for data visualization. These libraries are essential for anyone looking to work with data in Python, and I hope this video gave you a solid foundation to build on. If you found this video helpful, please give it a thumbs up and consider subscribing to the channel for more Python tutorials. APIs are how different software systems communicate with each other. Let's see how Python can interact with APIs to fetch data from the web. The requests library is a powerful tool for interacting with web APIs. In this example, we're fetching data from GitHub's API and printing it out as JSON. APIs are a huge part of modern software development, whether you're pulling data from a web service, integrating with third-party tools, or even building your own backend services. If you're ready to level up your Python skills, stick around because this video is going to be packed with valuable insights and hands-on examples. Let's dive in. Before we start, here's a quick challenge for you. Pick a public API of your choice and use Python to fetch and display some data. What did you choose? Share your code and findings in the comments below. All right, let's kick things off with a brief introduction to APIs. API stands for Application Programming Interface, which is essentially a set of rules and tools that allow different software applications to communicate with each other. When we talk about APIs in Python, we're usually referring to web APIs, which let us interact with services over the internet. For example, think of when you use a weather app on your phone. That app doesn't actually generate the weather data itself. It fetches it from an external service, probably via an API. Python makes it super easy to interact with these web APIs, and today, I'm going to show you exactly how to do that. Before we start making any API requests, we need a way to send HTTP requests from Python. The most popular library for this is called requests. It's simple to use and handles all the heavy lifting for you. To install requests, You just need to run the following command in your terminal or command prompt. Once that's installed, we're good to go. Let's start by importing it into our Python script. One of the most common API requests you'll make is a GET request, which is used to retrieve data from a server. Let's walk through an example using a public API. We'll use the JSON placeholder API, which is great for testing and prototyping. Here's how you make a simple GET request to fetch some data about users. This line sends a GET request to the specified URL. The response from the server is stored in the response variable. Now, you might be wondering, what exactly is inside this response? Let's find out. The response object we get back from requests is quite powerful. It contains all the information about our HTTP request, including the status code, headers, and of course, the content itself. A status code of 200 means everything went smoothly. Now, let's take a look at the actual data returned by the API. Since this API returns data in JSON format, we can use the JSON method to parse it. And there you go. We've got a Python dictionary containing user information. Each user is represented as a dictionary inside a list. Now, you can easily loop through this data and manipulate it however you need. Of course, not all requests go smoothly. Sometimes the server might be down, or you might hit an endpoint that doesn't exist. That's why it's important to handle errors and exceptions gracefully. Here's a quick way to check if your request was successful and handle any potential errors. By using raise for status, we can ensure that our script doesn't silently fail if something goes wrong. This makes debugging a lot easier. Here our request is successful, so there is no error. If we enter the wrong URL, then it will throw an error. Now that we've covered GET requests, let's move on to POST requests. While GET requests are used to retrieve data, POST requests are used to send data to a server. This could be anything from submitting a form, uploading a file, or creating a new record in a database. Let's try posting some data to the JSON placeholder API. We'll send a new POST object to the server. Here, we're sending a dictionary as JSON to the server. The server will return a response containing the newly created resource. Let's take a look at the response. As you can see, the server responds with the data we just posted, along with a unique ID for the new post. This is a common pattern you'll see when working with APIs. Not all APIs are open and free to use. Many require authentication, which usually means you need to send some sort of credential with your requests, like an API key or a token. Let's simulate this with a header. Imagine we're working with an API that requires an API key to access. Here's how you'd add that to your request. Adding headers is as simple as passing a dictionary to the headers parameter. This dictionary can contain any number of headers you need, whether it's for authentication, content type, or anything else. Sometimes you need to filter the data you're requesting, and this is where query parameters come in. Query parameters are added to the end of a URL to specify things like search terms, pagination, or filters. Here's how you'd add query parameters to a GET request. In this case, we're requesting all posts made by the user with ID 1. The params dictionary gets appended to the URL as query parameters. APIs can return data in different formats, the most common being JSON, but sometimes you'll encounter XML or plain text. The request library can handle these formats as well. Let's quickly look at an example with XML. If we print the content, you'll see it's raw XML data. To work with this data in Python, you'd likely use an XML parser or a library like Beautiful Soup for more complex structures. But the request library gives you the raw data to start with. When dealing with large data sets, APIs often use pagination to split the data into chunks. Understanding how to handle paginated responses is crucial. Here's a quick example using a paginated API. This loop will continue fetching pages of data until it fetched the desired number of pages, or there are no more pages left. This pattern is very common in APIs that handle large data sets. Before we wrap up, let's go over some best practices when working with APIs in Python. Rate limiting. Be aware of rate limits imposed by the API. Some APIs restrict the number of requests you can make in a given time period. Implementing a delay between requests or handling rate limit errors is crucial. Caching. For APIs that provide static or rarely changing data, consider implementing caching to avoid unnecessary requests. Error handling. Always handle errors gracefully. This includes checking for status codes, handling network issues, and managing timeouts. Documentation. Read the API's documentation thoroughly. Each API has its quirks, and understanding these can save you a lot of time and frustration. Security. Never hard-code API keys or sensitive data directly in your scripts. Use environment variables or configuration files that are excluded from version control. And with that, we've covered a ton of ground. We've looked at how to make GET and POST requests, handle errors, work with authentication, and much more. Working with APIs is a powerful skill, and with Python, it's incredibly accessible. I hope this video has made you feel more confident in your ability to interact with APIs in Python. Thanks so much for watching. If you found this video helpful, don't forget to give it a thumbs up, share it with your friends, and subscribe to the channel for more in-depth programming tutorials. No code is perfect, and errors will occur. But don't worry, Python gives you tools to handle these errors gracefully. If you want to write robust, error-free code, then stick around because this video is packed with insights and practical tips that will make you a better Python developer. The try, accept, and finally blocks allow you to handle errors and ensure that your program can recover from them. This is essential for writing robust code. Have you ever encountered a frustrating error in your code? Share your experience in the comments, and let's troubleshoot together. So, let's kick things off by talking about exception handling in Python. In programming, errors are inevitable. Whether it's a typo, a logical mistake, or something completely unexpected, errors will happen. The good news is Python provides us with powerful tools to handle these errors gracefully. An exception is an event that disrupts the normal flow of a program's execution. When an error occurs, Python generates an exception, which can be handled to prevent your program from crashing. Here's a simple example. We're trying to divide 10 by 0, which of course is mathematically undefined. Instead of letting the program crash, we use a try except block. The try block contains the code that might throw an exception, and the except block lets us handle the exception. In this case, we catch the zero division error and print an error message. But why handle exceptions in the first place? Well, without exception handling, your program would crash whenever it encounters an error, leading to a poor user experience. By catching exceptions, you can either fix the issue on the fly or provide useful feedback to the user, making your application more robust and user-friendly. Now, Python has several built-in exceptions that you should be familiar with. Let's take a look at some of the most common ones. Here, we have examples of value error, file not found error, and index error. Each of these exceptions handles a specific kind of error. When converting a string that doesn't represent a number, Python raises a value error. When trying to open a file that doesn't exist, it raises a file not found error. And when you try to access an index that's out of range, you get an index error. So, what are some best practices when it comes to handling exceptions? First, be as specific as possible. Catch only the exceptions you expect. This makes your code easier to debug and maintain. For example, catching a file not found error when working with files is more precise than catching a general exception. Notice how the first block is more explicit, while the second block is a catch-all. The problem with the second approach is that it might mask other issues, making debugging harder. Next, avoid silencing exceptions. It's tempting to just write except pass to get rid of an error, but doing so can lead to bigger issues down the line. Here, we're catching all exceptions but doing nothing about them. This might prevent a crash, but it also hides the problem, making your code difficult to debug later. Another good practice is using finally and else clauses with your try except blocks. The else block runs if no exception is raised, which is great for code that should only execute if everything goes smoothly. The finally block, on the other hand, runs no matter what, whether an exception occurred or not. This is perfect for cleanup activities like closing files or releasing resources. Now that we've covered how to handle exceptions, let's talk about raising them. Sometimes, you need to forcefully throw an exception in your code. In Python, you can raise an exception using the raise keyword. This is useful when you want to enforce certain conditions or indicate that something went wrong. In this example, we have a simple function that validates an age value.
If the age is negative, we raise a value error. This forces the caller to handle the exception, ensuring that invalid data doesn't propagate through the program. All right, let's move on to debugging, an essential skill for any programmer. Debugging is the process of finding and fixing bugs or errors in your code. There are several debugging techniques you can use in Python. Let's go through a few of the most effective ones. First up is the classic method, using print statements. Print statements are a simple way to see what's happening in your code. By printing variables and intermediate results, you can trace the flow of execution and spot where things go wrong. However, while effective, this method can be tedious and messy, especially in larger code bases. For a more powerful approach, you can use Python's built-in debugger, PDB. This tool allows you to set breakpoints, step through your code, and inspect variables. In this example, setTrace sets a breakpoint in your code. When you run the program, it will pause execution at this line, and you can enter PDB commands to inspect variables, step through the code, and continue or quit the execution. This approach gives you much more control over the debugging process. If you're using an integrated development environment like PyCharm, VS Code, or Eclipse, you've got built-in debugging tools at your disposal. These tools offer graphical interfaces for setting breakpoints, stepping through code, and inspecting the state of your program. Here's how it looks in a typical IDE. You can set breakpoints by clicking on the line numbers, and use the toolbar to step into, over, or out of functions. The Variables panel lets you inspect the state of your program, and you can even modify variables on the fly. Another great technique is using Python's logging module. Unlike print statements, logging can be configured to include different levels of information, from debugging to critical errors, and can be easily turned on or off. In this example, we configure logging to show debug level messages. The advantage of logging is that it's more flexible and can be easily integrated into larger applications. You can log messages to a file, filter them by severity, and format them in various ways. Finally, let's talk about creating custom exceptions and debugging them. Sometimes, the built-in exceptions aren't enough to describe the errors in your application. In these cases, you can define your own exceptions. Here, we define a custom exception invalid age error. This allows us to raise and catch exceptions that are specific to our application, making the code more understandable and maintainable. Debugging custom exceptions follows the same principles we discussed earlier. You can use print statements, the PDB module, logging, or IDE debugging tools to trace and fix any issues. And that's it. We've covered a lot of ground today, from handling built-in exceptions to debugging your code like a pro. Remember, exception handling and debugging are essential skills that will save you countless hours and make your code more reliable. If you found this video helpful, don't forget to hit the like button and subscribe to the channel for more in-depth Python tutorials. Python isn't just for data science. It's also a fantastic tool for web development. Flask is a lightweight web framework that's perfect for getting a web application up and running quickly. In this example, we created a simple web server that returns, "Hello, Flask," when you visit the homepage. Extend this app by adding more routes. For example, add an about route that returns some information about yourself. Share your app idea in the comments. Let's build a simple web app using Flask. Open a folder in VS Code where you want to create your project. First, we need to set up our development environment. Create a virtual environment first. If you don't know how to create a virtual environment, check out the previous videos of the Python series. Once the virtual environment gets created, we need to install Flask. We can do so using pip. Open your terminal and type pip install Flask. Next, create a Python file where we'll write our Flask application. Let's name it app.py. With our environment set up, let's dive into coding. Let's start with a very simple Flask application. Open app.py and write this code. This is the most basic Flask application you can write. Let me break it down. First, we import the Flask class from the Flask module. Then, we create an instance of the Flask class. The name argument helps Flask understand where to look for resources like templates and static files. This app.route decorator creates a route for the home page. When a user visits this URL, the home function will be called. It will return a simple string that will be displayed in the browser. App.run runs the Flask app with debug mode enabled, which is helpful during development. To run your application, go back to your terminal and execute this command, python app.py. Open this URL in your browser. You should see Hello Flask displayed on the screen. Congratulations, you've just created your first Flask application. Returning a simple string is nice, but web applications typically return HTML pages. Flask makes this easy with template rendering. We'll be using Jinja 2, Flask's default templating engine, to render HTML. Let's create a basic HTML template. First, create a directory named Templates in the project root. Inside the Templates directory, create a file named index.html and add this HTML code. Now, update app.py to render this template. Import the render template and update the home route to open index page. If you reload the app, you should see the updated index page. Web apps often need to serve static files like CSS, JavaScript, and images. Flask handles this via a static directory. Create a static directory in your project. Inside static, create a CSS file, style.css, and add this code to beautify the index page. After adding CSS, we need to link this CSS file in your index.html template. Reload the page in your browser, and you should see the changes applied by your CSS. Now let's add some more routes to our application. For example, let's add an About page and a Contact page. For these routes to work, you'll need to create About and Contact templates in the Templates directory. Add the code in both of these files. Feel free to design your own About Us and Contact pages. If you enter About route in your browser, you should see the About page. If you enter a Contact route, you should see the Contact page. Flask also allows you to handle query parameters. Let's modify the Contact page to accept a query parameter. Say we want to pass the user in the URL of a Contact page. We will get the user from the request and show a greet message on the page. Now, update contact.html to display the user's name. If you now visit the Contact page with query parameter user equals John, the page will greet John personally. If no user parameter is passed, it will default to guest. Web applications often involve forms where users can submit data. Let's add a contact form to our application. In contact.html, add a simple HTML form. If we visit our Contact page, we can see the form with name and message fields and the Submit button. Since we have a form to submit, we need to handle the form submission as well. Let's create a route to handle the form submission. This Submit form route handles post requests, retrieves the name and message values from the form, and returns a thank you message. Now, if we visit the Contact page, fill up the form, and submit it, we can see a thank you message. Instead of just displaying a thank you message directly, you might want to redirect the user to a different page after form submission. Let's implement that. For that, we need to import redirect and URL from the Flask. Then, replace a thank you message with the redirect function and URL function, with the URL where we want to redirect and the username. Now, when a user submits the form, they will be redirected to the thank you page. APIs are a crucial part of modern web applications. Let's create a simple API endpoint that returns JSON data. Let's add the user route to app.py. This endpoint takes a username as a parameter and returns the user's data in JSON format. Now, if you enter this URL, you should receive a JSON response with Alice's data. If you try a username that doesn't exist, you'll get an error message with a 404 status code. But we are using the static data here. What if we want to use a database? Most web applications require a database. We'll use SQLite, a lightweight database, for this example. Flask has excellent support for SQLite through Flask SQL Alchemy. First, install the package Flask SQL Alchemy. Next, let's set up our Flask application to use a database. Update app.py. Here's what we're doing. Import SQL Alchemy and configure the database using app-config. We configure the SQLite database using SQL Alchemy database URI. Define the connection string for a SQLite database named users.db. Then initialize SQL Alchemy with the app instance. storing it in the DB variable. Here we create a user model with fields for ID, username, and email. We use db.createAll to create the tables in the database if they don't exist. Now let's add some data to our database. We'll do this by adding a new route for creating users. The add user route adds a new user to the database. The get users route returns a list of all users in JSON format. Let's test these routes. Let's add user John with an email ID John at example.com. We can see the message user John added to the database. Now, let's check if the user is added successfully by visiting the get users route. As we can see, this route shows the added user John. Try adding more users and let me know in the comments below if it works successfully for you. And that's a wrap. We've covered a lot of ground in this video, from setting up a basic Flask application to working with templates, forms, APIs, and databases. I hope you found this tutorial helpful. Building web applications with Flask is incredibly powerful and flexible. And with the knowledge you've gained today, you're well on your way to creating your own applications. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell so you don't miss any future content. Leave a comment below if you have any questions or suggestions for future videos. Thanks for watching, and I'll see you in the next one.